And maybe we can start with where we left off with our question. Hopefully you had some time to go through and figure out how to modify your plot as we were requesting you to do. And I did just write on the board here, hopefully you could see that if you want to know how to do this kind of shorthand formatting of the plot style in Matplotlib, the easiest thing to do is to search for Matplotlib, pyplot, and then plot, which is the plotting library that's used by default for making plots in Matplotlib. And if you scroll down to the bottom, there is the section on line styles. That's what we needed, was to be able to make a dotted line. So you can see you use a colon character to make a dotted line in Matplotlib here. And then it's also the reference for the shorthand notation for the colors, where you can see again that B is for blue, K is for black, and intuitively in this case the letter R is for red. And that information is available in the Matplotlib documentation. There's also a whole bunch of different symbols that you can use for the markers, which is the Matplotlib terminology for the symbols on the plot. We had been using this O to make a circle symbol, but if you wanted to use instead something like a square, you can use the letter S. If you want to use stars, you can put an asterisk character in there, and there's other options as well. But our task back here, I'm going to just get rid of this cell where I looked at the help documentation because it's taking up half of our notebook. So bye-bye to that one. Our task was to take the plot above and modify it. So step 1, copy. Step 2, paste. And we wanted to make the following modifications. Temperature data from 6 p.m. till midnight. So that means our starting time instead of 12:00 is 18:00. Our ending time instead of 3 p.m. would be the next day at 00:00, so midnight on the 2nd. And that's our range of temperatures. We wanted a red dotted line connecting the observations, so that's going to be our style, which we're going to replace with an R and then colon, because that's how we get our dotted line and make it red. And we don't want to have a symbol shown, so the O goes away for plotting the symbol. Title that reads this text string here, which again, because we are smart, we'll just copy and paste that rather than typing it in. And finally, text label indicating the warmest temperature in the evening. So this is the only part where you probably needed to kind of tinker a little bit, because you have to run this first. We can, I guess, make this be warm time instead of cold time. And then where we display it, we can say warm time. But you got to basically run this and make the plot. And then you'll see when you do that, that we have this text label that's way off the axis of our plot because it's referring to a time much earlier in the day. So obviously that's a problem. But also we need to look at the plot and say, oh, okay, it looks like, did we miss our temperature range in here? Maybe we should have adjusted that as well. But you can see, for instance, here at maybe, I don't know, is that like 10:45 or something like that, is the warmest time of the day. 43 degrees Fahrenheit. And we're going to put our text in, but it always uses the leftmost side of the text to define where it's going to be displayed. But we could say, for instance, that the temperature would be 43. We'll increase that. We'll say warmest time of the evening. And we'll make our arrow on the other side because we don't want to put this on the left. We'll put it on the right. And just roughly estimating, I don't know, I'd say sometime around maybe 9 p.m. would be a good spot to put the text because it's going to be displayed to the right of 9 p.m. So let's make our warm time be, instead of 12:05, let's make it 21:00 and just see how this looks. So we run it. Warmest time of evening, you can see pointing over here. So 43 degrees is the right temperature. It could probably be 15 minutes further or 20 minutes further to the right. So we could adjust our time to be maybe 21:20 instead of 2100. And that looks close enough for our purposes here. Again, there's other ways to do this, but this is just an example of how to add some text annotation to a plot. Any questions or issues with making the plot here? I can maybe just show this for a moment if you want to see what was used for making the plot. As I did go through it a little bit quickly, but yeah. You can also, if you go to the book page, you'll find this example there. So you can take a look at how we did it in the book as well. I would guess it's not a lot different from what's shown on the screen here. But a couple other things we can do here quickly before we move on to our other part of today's lesson. Yeah. I mean, there's a few different ways to do annotation in Matplotlib. So there are some in which you can identify a point where you want to annotate this point and then have some kind of reference line that connects the text. So it can even intelligently place the text and then have a line connecting it to where you want. In this case, it's the kind of quick and dirty method, which is to just adjust the XY position until you get the plot to show the text in the right spot. A lot of times when you're making plots like this, there's some kind of formula you can come up with for where you want to position the text, whether you're labeling it on the right, left, above, or below. And this is just the kind of quickest way to do it. But it's obviously not the nicest. But, yeah. Okay, so we've got a couple other things to do here. If we take our example from what we were plotting earlier, we had the afternoon of October 1st. I think we did this maybe someplace earlier. I'm going to take our example plot from here and just modify this a little bit. Well, actually, maybe not. So let's say October 1st afternoon, we have oct1 temps dot loc, and then we'll use our loc accessor to give us the location where oct1 temps dot index is greater than or equal to, and then 2019 1001, and then 1500 for the time of day, 3 p.m. Then we've got a lot of the same stuff we had before. If we want to make a plot, we can say AX equals. And if you want to just maybe, well, you can type this in if you want to, but I'm going to type a little bit quickly here because it's probably I could scroll up in my notebook and find a place to copy paste this because we've already done this. But we could take, for instance, oct1 afternoon dot plot. And the thing we're going to change here is we're going to change the kind of plot, instead of being a line plot, to be kind equals bar. That's the only real change here. Otherwise, this is stuff we've already seen. In fact, I'm going to skip over the title and axis labels in the interest of time because we've seen how to use those. The limit for the temperatures, for instance, we could set our y-lim to go from 40 to 46 degrees. Which we will set because I think otherwise it might default to 0, which looks a little silly with our just afternoon temperatures. We don't need to add a label or change the figure size or add a text label. We'll skip that stuff and just make our simple bar plot because that's all we wanted to do here. Now, did I? Okay. I think I did this backwards from what I meant to do, which is instead of greater than or equal to, I want to do less than or equal to. So I want the early afternoon only. So between 12 and 3 p.m. That looks better. So the bar plot, I mean, this is the same data we've looked at in some of the other plots already, where we had it as a line. This is just showing the same data as a bar. And you can see each one of the bars here is labeled by the time at which the observation was made. So here's 12 o'clock, 12:20, 12:50, 1 o'clock, etc. And now we have bars representing the vertical. So this is the temperature. I've kind of shortcut things here by not putting the axis labels on, but you guys have seen how to do that. So if you want to see the full example again, you can look on the book page for the case where we've added text to this, but it's nothing different really from what we have done. Other than, maybe I will show the text example for this case, because if we want to do ax.text here on a bar plot, it's actually easier to use the index for which bar you want to put the plot text label above rather than using the date. So we could say, for instance, here, if we want to put text above, let's say 0, 1, 2, 3, 4. So let's put it above index number 4. And we'll say a temperature of maybe, I don't know, just a little bit above this bar. So let's say 45.2. And we'll say warm. Whatever. This will position text above the value where you have an index of 4. So it's 0, 1, 2, 3, 4. In terms of the bars, it starts from the indexing on the left side of which bar is shown and adds the text there. I think it's a little bit trickier to do it with a date label for positioning the text on a bar plot. But it's also not that common that you put annotation onto bar plots. So it's maybe not such a big deal. We could dig up a method for doing this, but that's, I think the reason why we show this example using the index is because it's a lot easier to do it that way rather than labeling with using the date. Because it kind of, yeah, bar plots are a little bit funny with how they reference things on the x-axis. So making bar plots, though, is pretty easy. You can find other examples in the pandas documentation. So if we go here to pandas documentation and you scroll down to where it says kind, this is about the bar plot itself. But there's other examples for making plots. I don't know where in the documentation list here. I think I thought this was a different link than it is. But if you did look up the documentation for pandas plotting, for instance, this is only bar plot. I don't know if I can get there quickly by just deleting that to get dataframe.plot. But you can find in here under kind the different types of plots that you can make by default in pandas. And you'll see there's a decent number of them that you can choose just by changing this kind parameter when doing, whatever data.plot. So you could do bar h to make a horizontal bar plot. You could make box plots with just saying kind equals box, or pie graphs, or scatter plots, whatever. You can do those by selecting the different kinds, and obviously depending on the style of plot, you'll have different formatting options available as well. Maybe the last thing that we can cover here in our basic plotting lesson, as far as kind of typical things you'd want to do, is saving your plot as an image. So to do this, you basically produce the plot the same way you normally would, and you add one thing at the bottom, and that is this plt.savefig. So this is actually a Matplotlib savefig command, and then you give a file name, and a file extension will determine what type of file is going to be written for your image. So if we just copy this text, for example here, we can go down here. There's 2 empty cells. We can paste this in. This will give us our early afternoon temperatures in a bar graph. It's basically the same plot we just made. Now properly formatted to show where the coldest temperature of the time of day is. So our plot gets displayed just like we would expect before. But if we go into the file browser, you'll now see there's this barplot.png file that has been produced by the plt.savefig command. And if you double click on that, it's basically the same graphic that we were just looking at. So nothing really too surprising here. But it's quite simple that you just add this to save your plots to a file. And there's another example here. If we want to make a high resolution bar plot, this is the same plotting stuff that we did above, but we can do plt.savefig. We'll give it a different file name, give it a PDF extension, so it'll save that as a PDF. And then by defining this DPI, this is dots per inch, which is one measure of the resolution of an image, to be 600 DPI, that's quite high resolution. We can run this example here. We get another plot that looks just like what we were looking at before, but also if I click refresh, we now have this PDF bar plot that showed up in our file list in the file browser. And when you double click on that, you can see first off, there's the plot as it looks. And if you put it to actual size, you'll see it's a fairly high resolution image. You can kind of scroll or zoom in and see that it's quite high res picture. So if you're saving figures for a thesis or something like that, it's kind of nice to set the image resolution to be high for those examples. Our final example is a case of doing an interactive plot, and this is a fun one, so it's worthwhile to take a moment and just show you how to do this. For this, we're going to use the hvplot library, and we're actually going to import the hvplot submodule for plotting with pandas. So we can do here import like we would import a normal library, and we'll do hvplot.pandas. That'll give us our pandas plotting extensions, which is kind of a transparent thing that WholeOfViews does. That's this hvplot is using the WholeOfViews library. You run that one. Of course, you don't get any output because you're just importing a library. I think there actually is some little white space that shows up here. But we've got some data selection here for July of 2014 from our original data set. And then we can do our July 2014 data frame. And normally we would do .plot to get this to display in pandas. We'll do .hvplot. And then we'll list a few things here. So we can give a title. And let's just call this Helsinki Vantaa temperatures, like what we had said before. Then we are going to have our X label for our date. Label is date. Y label's temperature. So nothing new here. Temperature in, let's say, degrees Fahrenheit. And we can set our Y limit. Because it's summertime and it's warm out, to go from 45 degrees to 90 degrees Fahrenheit. And then close our parentheses. So as far as things go, this is pretty much no different than plotting in pandas, except we have HV in front of the plot instead of just saying whatever dataframe.plot. But when you run this, you'll get output that does look a bit different. So now, of course, we have selected a month of data, so you can see it goes from July 1st to the end of the month. But when you mouse over the values in the plot, you can see the value for the temp on, it looks like the 9th of July at 8:20 in the evening was 73 degrees. So this is a bokeh plot, and it means that we can do things like we can zoom in. So if I just kind of scroll, I can zoom in, I can click and drag things. I think I should be able to see a little bit more stuff than I can here, maybe because I'm too far zoomed in. I lost my bokeh bar. But over here, I can do things like refresh the plot to its original size. If you click on different values in the legend, it will make them visible or invisible. I don't think we have any max or min temperatures, but by clicking on temp, you can see it kind of makes it, it's not fully invisible, but transparent. If I want to, I can save the figure. I can do things like wheel zoom or box zoom. So I can click on box zoom and then say, okay, well, I really want to know what was going on this time of the month. I should be able to click and select some range and zoom into that. So this is handy and fun to play around with, especially if you want to make your data sets interesting to interact with. You can do that using the whole of view is quite easily almost a drop-in for the replacement of pandas.plot function. All right, so we are a little bit maybe behind schedule time-wise, but are there any questions about plotting so far? Okay. Our next part of our lesson is about creating subplots, and this is essentially, in the matplot terminology, a way of making several plots that are part of a single figure. So here we have 4 plots that are tiled together into a single figure in Matplotlib, and we can do this, for example, with our Helsinki-Vantaa Airport temperature data to separate things out by different seasons. So for instance, winter, spring, summer, and autumn. We can make plots for each time of year showing how the temperatures vary during those times of year, put them all 4 together so that we can see what kind of temperature data we're dealing with. Our first step is reading in the data file. This is identical to what we did earlier, but we have a new notebook, so we have to read the data file again. Just going to run the cell to do that. There's also a little renaming that we're going to do because we'll convert our temperatures from Fahrenheit to Celsius, but we can just run this cell to rename the temp column to be called temp_f. This is using the dataframe.rename function we've already seen and giving a dictionary for the column names to replace. And again, that's kind of nothing too special there. At this point, we can look at our data set itself by doing data.head, and you'll see the same thing we had before. Now our temp column has been renamed to be called temp_f, and we have some missing data values, and we can maybe figure out how many of those we have by doing data.isNA.sum. So the data.isNA will tell us, for instance, how many missing data values there are in our different columns of our data frame, and then .sum will sum up the total number of those values. So we can see, for instance, in the temp_f column, we have about 3,600 missing temperature values and many more missing from the min and max columns. So if we wanted to, we can basically drop out the missing values from the temp column by doing data.dropNA. We've done this before. With a subset equal to our single column temp_f. So remember, for the subset, this should be a Python list. And inside there, we have just a single value for temp_f. And we're just going to say in place equals true for this scenario, so that we just drop this and save the change in the data frame. And what we could see if we wanted is how many rows we've lost from our data frame, but we don't need to do that. We're just going to drop this. And actually, the easier thing is if I go back up and run the cell we ran before, when you run this data.isNA.sum, you can now see there are 0 missing values from the temp_f column. So looks like it worked. We're going to skip our question 4.2 because you can do that on your own if you like. But we're going to convert our temperatures first, make a new data frame column. So let's make one called data. Let's call it temp C, where we take our values in data temp_f. And we take that minus 32. Let's put this in parentheses. So put that whole thing in parentheses and then divide by 1.8. This is our conversion factor to go from Fahrenheit to Celsius. We could make a function for this and apply it. You'll actually have that task in the final exercise for the course to do it with a function, but this is our kind of quick way to do this without defining a function here. So you take temp_f minus 32, put that in parentheses, divide by 1.8. And if you run that cell and then do data frame or data.head, you should see now that we have one new column for temp C, and the temperature values are showing here. And these look, at least visually, to be right. So we just cleaned our data set and made a simple temperature conversion, nothing too fancy there. In order to make our subplots, though, we want to select ranges of dates for the different seasons to plot, for instance, for the year of 2013, what the temperatures were for winter, spring, summer, and autumn. And we can do this by doing a selection from our data frame using data.loc. What we want to do here is select the values, where we'll put this in parentheses, our data.index value is greater than or equal to the start of the winter of that year, which is actually going to be greater than or equal to 2012. So 2012, and we'll say December 1st, so 12/01 at midnight. So then 0000. So our location is, we're selecting based on the index being greater than 2012, month of December 1st, and midnight on that day. We want this winter to be true that starts then we'll do this bitwise and I could put another set of parentheses. We'll say the data.index needs to be less than 2013 and the month of March and the first day of March. So 0301 and again 0000 for midnight on the 1st of March. This should be selection. So the starting day would be December 1st, and it would go up to but not include 1st of March. So that would get all of February. So it would be December, January, February in the winter. Yeah. And then the next one will start basically from this same ending date for the, yeah. So that will give us our selection of dates, and then we're just going to make a column or a single data series called winter temps that's only the temp C value from that winter data frame. So let's copy this one and paste it down here for the spring, and we'll modify things just a little bit here. In fact, the easiest thing to do here is to recognize that we want to continue from where we left off. So let's take our 1st of March of 2013 as now the value that we'll put in here as our starting date. So I'm just copying this one to be then here as our starting date for our data. And our ending date should now go up to, we want March, April, and May. So it should go up to the month of June, but it's not going to get June because it's less than the 1st of June at midnight. So that will go to the very end of May, but not get any dates from June. We can again copy this data location selection down here for the summer, and let's just go ahead and paste it in for the autumn as well, because it's going to be the same process. What we'll copy from our ending condition for the spring, we'll go for our first value for the summer. So we'll just paste in the value that was here so that we start from the 1st of June. Then we want June, July, and August. So we don't want September, which is month 9. So we go up to, but don't include month 9 here. But then that's going to be our starting point for our selection for autumn. So we'll paste that one in here. And in this case, we want to go up to, but not include month 12. So we don't want to get December, but we want all of November to be part of the autumn in our selection as we're making it here. So a little bit of copying and pasting things, and you can run this cell. And what you should get is that you'll have a winter temps, spring temps, summer temps, and autumn temps as a pandas series. We could, for instance, say AX1 equals winter temps dot plot, like this. Run it, and we can see here December 1st, 2012 up to, but not including the first day of March in our selection here. So these are indeed our winter temperatures, and they're in Celsius now, so it looks more like a winter temperature than what we saw before. We could say, for another example, AX2 equals summer temps dot plot, and run that one to get our summer temperatures, which again look more like typical summer temperatures for our region, somewhere in the vicinity of 20 degrees Celsius as a typical daily temperature. Whereas in the wintertime, it's maybe hovering closer to -5 as a typical temperature. So the key to this is that we're just selecting values in this way. And if you're having issues, most likely it's just checking these date strings are properly formatted, because that's an easy place. If you get one number off, you will miss out. Like if you add one number here by accident, you're going to now have a condition you can never meet, because this is comparing a date that it may actually even complain it doesn't know how to scale that date. So you'll have issues if you have things kind of not correctly formatted for the date part of the selection that's done here. But at the end of this process, you should then have 4 seasons worth of data. We can do this kind of data bounds selection as our next step. This is typically done where what we want to do is find out what's the minimum and maximum value in our data set to be able to have all of our plot axes be the same in making our subplots. So to find the lower limit for the y-axis, we could say, all right, let's take the minimum temperature from all of our different seasonal data sets and maybe subtract 5 degrees just to add a little bit of padding so that the line doesn't go right to the bottom of the plot, but we'll give a little bit of extra space. So we could say that our min temp, for example, would be equal to the min of winter temps dot min. So that's going to find the minimum temperature in the winter. We want to take the minimum of several different values. So we'll take winter temps dot min, spring temps dot min, a lot of typing here, sorry. Summer temps dot min, and finally autumn temps dot min. So this is going to find the minimum temperature for each one of these seasons and then take the minimum of the 4 numbers that it finds there. So it kind of finds the absolute minimum temperature. We could do this other ways, but this is the kind of typical way you would do this if you have seasonal data. And then we said we wanted to add a little bit of space beneath that minimum temperature. So we can say that min temp equals min temp minus 5 degrees. So this will just give us a bit of padding. Again, we could adjust the padding in other ways in plotting things, but this is a simple way to do it, just to give us a bit of extra padding. Let's copy paste this for finding the upper limit. So just pasting in what we had above. Now instead of min, we want max temp. So essentially any place you have a min, you change it to be a max. So now we're finding the max of winter temps dot max, spring temps dot max, summer temps dot max, and autumn temps dot max. Again, we're going to say the max temperature is max temperature, and instead of -5, +5. A very similar thing to what we did above. Instead of taking the minimum and subtracting, we're just taking the maximum and adding something to it, which will give us a bit of extra space above the maximum value that would be displayed on the plot. When you run this cell, you should get a minimum temperature of -35 and a maximum temperature of +35. It's a coincidence that it happens to be symmetric here, but it works out in our favor because that also looks nice when things are symmetric. I think visually that's a nice situation. How is everybody doing with this? Are you kind of with it so far? Yeah. Mostly. I see some discussion going on, but it seems like generally people are kind of along to this point. Well, let's take a look at how we can make a set of plots that are tiled using, in this case, Matplotlib. What we're going to do is a little different than what we did before, which is we're going to say fig, axs equals plt.subplots, which I always type as subplots for some reason. I don't know why. But plt.subplots is the Matplotlib function that allows us to make a grid of plots. And we can say, for instance, n rows equals 2. N calls, so number of columns, equals 2. And we can set a figure size at the same time. So fig size equals, again, remember it is a tuple, so it should be in parentheses, but let's go 12, 8. So 12 inches wide, 8 inches tall, or 30 centimeters and 20 centimeters for dimensions. And then if we type axs, this will display our axes. So you can run this and you see now that we have these 4 empty plots that have been created by the subplots command in Matplotlib. What is a bit different here, as you can see, is that we have 2 values that are getting assigned from this plt.subplots command. We have something that will allow us to refer to the figure, that is the 4 plots together on this kind of broader enclosing thing where the plots axes exist. And then this axs, which is basically the same thing as what we had with our ax equals plt.plot or ax equals data.plot or whatever before. We're calling it axs because we have multiple plot axes here. And what you can actually see is that when we display this, it shows that this axs contains an array where we have 2 sets of axes in a Python list. That's the first 2 in the first row. And then we have a second set of 2 plot axes in the second row. And that's what's shown visually then down here. So our axs value, that variable actually contains 2 Python lists that are nested inside one another that gives us a way to reference each one of the individual plots. It turns out that's kind of a nice thing, but also a bit of a hassle. So it might be easier for us if we say, for instance, that we could call a variable ax11, which would be, let's say, our top left plot. So row 1, column 1. That we could say is equal to axs 0, 0. So this is giving us the 2 coordinates to find our plot in the axs object. I'm going to copy this and paste it 4 times here because you might be able to guess already what we're going to do is we'll make ax 1, 2. So second plot in the first row, and that's going to be axs 0, 1. We don't need to do this. It just makes it easier to refer to which plot we're manipulating by renaming and assigning these variables. Then if we go to the second row, we can create a variable called ax21, which means row 2, column 1, which is just going to simply be axs 1, 0. And then ax22 will be axs 1, 1. It's a little bit easier to type in ax11 than typing in this when we want to do stuff with the plots. So that's also part of it. So we run that, we just rename the ways in which we can reference our plots. And then we have some things here that are already filled in for us, like creating our set of plots, redefining the references to them, setting a line width to be a little bit wider than the default, which I think is 1.0. And then if we want to plot our data, we could do something like winter temps dot plot. And we can give some things here like which axes do we want to use? We can say AX equals AX11. So this is now telling the plot command which one of these 4 tiled plot things should we actually display our plot on. And we say, well, let's put it in the top left, AX11. Then we can say the color equals blue. So we didn't show this earlier, but you can also assign things like a line color using this shorthand notation C. I think it's the same as if you type out color, but C equals blue is the kind of shorthand notation for it. LW is used for line width, and we can say that's equal to this line width variable we defined here. And then we can say our Y limit, so the range of values along the y-axis, is equal to, this is a Python list again, min temp as the minimum, and max temp as the maximum. So we calculated before what those bounds should be. We want to have all 4 of these plots have the same range of values on the y-axis because it's easiest to then compare them to one another, and we can do that like that. Let's copy this one. Paste it here 3 times. Probably, if your fingers aren't getting tired yet, you know the drill here. So now we're doing spring temps. We're going to do AX12 for this one. The color, let's make it a nice spring color. I think it's orange in this case. Although green might seem like a more logical choice. Let's change it up. Let's make it green today. Dreaming of the spring perhaps already. We don't have to change anything else here because our line width and our range of axis values are the same as they were before. Next line down, we'll have summer temps. This is going to be on axis 2, 1. The summer's hot, so we can make this red, I guess. It won't look maybe as nice as the example plot we showed at the beginning, but we'll make it. That's a hot summer, so we can make it red. And finally, then we have autumn temps on axis 2, 2. And for this one, we could say maybe orange. It's kind of yellow and orange out there right now. And we don't need this plt.show thing, but it just suppresses some extra text from being written to the screen, so that's why that's here. So if we run this, then we see in our nice blue our winter temperatures that are kind of cold. Again, that's AX11, so top left. AX12 is our spring temperatures. We can see here it is, warming from the winter toward the summer. The hot temperatures in the summer shown in red, and then the temperatures in the autumn cooling down in the sort of orange color. We could make that brown if we want to kind of make it a more depressing. The brown's kind of ugly though. It's not really brown, it's kind of maroon. I don't really like the color that they, maybe it's just my screen, but it doesn't look very nice. Anyway, that's how we can make the subplots. And if we take what we had above, we can fix a couple things. You might notice there are some issues. One, it's kind of hard to tell what season's which, right? There's nothing in here telling us which season it is other than the dates. So the attentive viewer would notice the dates and see that this this could be referring to different seasons. We also have issues that the text is being kind of hidden behind some of the other plot windows, which is not so nice. And I think there is an option in Matplotlib. I don't think it will solve our, yeah, it will. So there's plt.tight layout. I don't know why it's called this, but I think it's for when you have plot elements that are kind of close to one another, Matplotlib can figure out whether they're going to overlap with one another. So you can use plt.tightLayout as one possibility to give a little bit of extra space so that then our axis labels and our plot elements don't stack on top of each other, which is nice. Again, if we leave that out, or if I just comment it out here, you can see that we had the issue that our text is kind of being overlapped by our plot windows. But there's other ways we can do this. We could also fine-tune the angle at which the text is labeling the axis to avoid that overlap. That's what's shown in the example that is shown down here. I think we can add our winter plot stuff in here, but this rotation thing that's shown here is an example of just rotating the axis label to avoid the overlap. I find that to be kind of a bit clumsy, so I don't really do that myself. I think I just use this tight layout thing because it's fast and it solves the problem in most cases pretty easily. But our winter plot, we can add on here. The spring, summer, and autumn are already here. So let's just add in winter temps.plot in our refined version of our plot that we generated above, where we're going to add some axis labels. We're going to add a grid to be able to see more easily the values for our temperatures. We can add a subtitle, which is like a title for the whole figure. So not just an individual plot, but the whole figure. And we can add some text on the plot to tell us what season it is. So we'll do that by defining here winter temps, like what we've done earlier. Our AX is going to be AX11. Start with that. Color, I think we said for winter, we're going to go with blue. Let's stick with that. Line width is still going to be the same as it was, line_width. And our Y limit is going to be the same as it is for all the plots. Let's just copy paste that from the example down below and set our grid to be equal to true, which will add grid lines on the plot. That's how you do that in the pandas plotting. So it's very similar to what we had above so far. We just added the grid equals true thing here. Then we set the figure title. That can be done down here by doing plt.sup. Is it sup_title? Or is it just subtitle? I think it's just subtitle. And that could be, let's say, 2022-2023 seasonal temperatures. There's more stuff on the example plot, but we'll just leave this kind of at that for the sake of not making you type in much more. Then finally, we have a text label for which season it is. You can see the other three seasons are already done for you, but we can do our AX11.text. Let's copy this PD to date time thing. It looks like here we have May 15th, August 15th, November 15th. It's always like 15 days from the end of the period here. So let's say February 15th. So 2023-0215. And we'll make this -25 like the other ones in terms of the Y position so that the text is consistently located like that. And we'll say winter. We run this one, and if all goes well, it didn't because I didn't close my parentheses here. And I also didn't close my parentheses somewhere else. It seems series object is not callable. Right, because I need the dot plot. There we go. And now we have basically the same plot we had before. However, we have added the text labels on here, which is nice. Easy to tell now these are winter temperatures. The grid lines are handy, of course, because then you can much more easily quickly look on the plot to figure out how much the temperature varied and see that, yes, indeed, it did hit almost -30 in January of 2013. And and the other seasonal temperatures are kind of a bit easier to read with the additional notation here. And you can see that the rotation of the label text on the axes has eliminated the overlap between where the text labels are and the figure boxes themselves. So like that, you're able to generate these kind of sets of subplots and visualize things like seasonal temperature data, which is something you will do in the final exercise for the course as one of your kind of main outputs from that exercise.
Can you scroll a bit up?
Yeah, yeah. Was it which part, further up or? Yeah, this. Yeah. It's kind of, this is pure Matplotlib clumsiness for dealing with how to rotate the axis labels, but it's, yeah, whatever the axes are, .x-axis, .get major tick labels, and then rotation equals some number. So if you wanted to make them vertical, you could do rotation equals 90. If you wanted to make them, even less inclined, you could lower this number, but then at some point they'll start overlapping with each other just in the text. But, yeah.
Can we increase the gap between the rows?
In here, increase the spacing. You can. I think there's a padding thing that you can adjust to do that. If I'm being completely honest, what I do 90% of the time is just plt.tight layout, because it generally puts enough space that it looks pretty good. If I'm working on a figure like this in a, let's say like in a journal article or something like that, most of the time I get it looking 80 to 90% to being finalized in what I do in Matplotlib, and then I export it and adjust some things in like an image editing software. So sometimes it's just too much of a hassle to get Matplotlib to position things exactly where you want, and it's just faster to export it as like a editable image format and then move a few things around. A good example would be like when you have labels on contour lines, Matplotlib always puts them in kind of funny places, so it's just nicer to move the labels myself once I have the figure. But yeah. Any other questions about the subplots stuff? Yeah. How far do you want me to go up to the? Yeah. Do you want to see like this winter plots? So what we did here is the only change is, compared to what we had above, is just adding this grid equals true. This is very similar otherwise to what was above in the previous cell up here, I think. Well, I'll just copy paste it so we can actually compare one to one. What we had before looked like this. So AX equals AX11, that's the same. Okay, I had written color equals blue instead of C equals blue, but that's the same. Line width and the Y lim. The only thing that's been added here is this grid equals true compared to the earlier example. And then we did define this subtitle. That's the text that goes above the whole figure, as you can see here. And then we added positioned the text using this PD2date time thing to get the winter. In this case, we put it to be February 15th as the date, just to kind of get the text position to be always consistent relative to the other plots. But there's other ways we could do this. We could have changed the title, but it's, yeah. And I don't know why, for some reason, it didn't put our axis labels. Oh, I guess we don't have an X label or a Y label. Okay, well, we should. Let's add these X label and Y label in, as they are missing for the spring and the winter. Doesn't matter what order they go in because we're labeling the parameters with their name. So now we've added those in, which now we get temperature and date. in all honesty, if I made this plot, I probably would not include an X label on the top panel because it's the same thing as the lower panels and it's kind of redundant to have this extra text there. It's clear enough that it's a date, so I would probably omit the X label here, and I would probably remove the Y label on the spring. So in reality, I would probably make this so that there's no X label for the winter or the spring, and Y label for the spring would also be gone. So actually maybe that's by design. But then if you don't label it, then it puts in this name of the column in its place. So maybe we should do this and put some dummy label there. Let's make our X label be empty. And see if that solves our problem. Yeah. So anyway, I'm kind of just going off deviating from the script at this point and showing you a few other plotting things. But typically when you have these groups of subplots, to maximize the space you have to see the data, I like to take away unnecessary labels for the axes. So this saves a little bit of space, makes it a bit of extra space to see the data itself. And yeah, that's it for our subplot stuff. There's one more part of the lesson that I think I will leave to you to look through. But if we go back to our plotting and Python stuff, there is one other thing about effective line plot design that's it's about accessibility and inclusivity for making data visualizations. There's some hypothetical scenario here where we have these temperatures for different mythical lands. And you can see, for instance, here, 1 year of temperature data from the year 1680. I don't remember why we chose that, but you see 4 different color lines. At least something like 85 or more % of you would see 4 different colored lines. But not everybody sees color the same way, and that can be an issue. And if we take this same data set and we printed it, like just using a typical black and white printer, you get something that looks like this. And obviously the challenge here is now which one of these lines is represented by the data that are labeled here. An easy way to deal with this issue when making line plots, and this is something that's kind of a good habit to get into whenever you make line plots using any kind of software, whether it's using Python or something else, is to change the line style for each one of the lines that you want to have on there. So you can have the color on there. Color is a nice visual thing for a lot of people. But also, by changing the style of the line, whether this is shown in grayscale or it's viewed by someone who has some kind of color blindness, you can tell which line is which because you have a different line style. So we can see, for instance, that Camelot has this dashed line, or dotted line rather, and Noosa has this dashed green line, and Asgard has the blue solid line. So there's just kind of it's not quite a good coding practice, but just something about making your data available to as many viewers as possible by making a very small thing and just changing the line style when you have multiple lines. It's really not that common that you have more than 4 or 5 different lines on a single graph, and that you actually want to distinguish them. If you have a whole cluster of lines that are all showing the same thing, you don't really need to distinguish one from another, but very often just by changing the line style with a few different lines, you can make it so that anybody visualizing or viewing the data can see it equally well. So that's on the course page. You can have a look at that. But let's take a look at our exercise stuff because it's about that time. Exercise number 7. As it will come perhaps as no surprise to you, it's about data visualization. And it's a 2-problem exercise. First off, due date. It is due 1 week from today by the end of the day. We don't have class next week on Monday, but I think the exercise itself is maybe not as heavy as the previous 2 weeks exercises. And it's good for you to get this into us by end of the day on Monday next week so that the course assistants can grade it and get it back to you so you can have some feedback when you're working on the final exercise. So yeah, just be aware of the due date, end of the day on Monday, 1 week from today. As I mentioned, 2 problems. First problem is about making a fun little candy plot, which is just practicing doing things with plotting using Matplotlib. The thing is, we are also going to use NumPy in this, and so you're given some instructions about how to do that, because we're basically plotting randomly distributed points in an XY plot that's this kind of scatter plot that's colorful and fun to look at. And you need to know how to do things with NumPy, so there are some tips about how to do that on the course page. It's pretty simple, but basically we're going to fill in some values using NumPy in a data frame that has column for X and Y that has random numbers for 1,000 different points. And then we make a colors thing that has a random values, and then you produce a scatter plot by looking a little bit into the documentation for pandas about how to make scatter plots and producing this plot that looks something like this. It won't look exactly like this, but it can look similar. We'll have different colors most probably. And then save that plot as an image file and upload that to GitHub. That's the first problem. Second problem is plotting temperature data. This is perhaps more close to what we've done during today's lesson, but your task is to take a data file, read it in, and make a plot that looks something like this for, I think this is maybe 30 years of temperature data. I think these are maybe mean temperatures monthly or something like that. I don't recall. But you can find a description of the data set and what you read in here. And then the exercise walks you through the different steps about processing the data to be able to produce a plot that looks like the one that is shown at the top of the description of the exercise. And again, you'll save this as a figure file and upload that to GitHub. So please be aware when you push your changes, you should push your notebook, but you should also push the data file, or the figure file rather, that you have produced. And there's an interactive exercise as an optional thing at the end. If you want to just practice using hvplot, you can also make an hvplot visualization. That is that, and then about the final exercise. So you can find some information on the course page about this. The due date for the final exercise is November 8th. That's a Friday at the end of the day. I think it is something like 3.5 weeks from today, something like that. It should be the case that you have 3 weeks or so to work on it after the exercise number 7 is due. So there's a lot of time. It's also worth 40% of the course grade, so there's proportional amount of work that goes along with that time that you have. So part of this is that we wanted to give you 2 weeks of time to work on it. That's not the study and exam week, so that's why the date is what it is. But you can find the description of the exercise, which I guess I already have up here, on GitHub, where it tells you what the task is that you have to do in this case. Your goal is to make a 4-panel plot. Looks somewhat like what we did in today's class. But instead of presenting temperatures, what you're going to plot are the temperature anomalies. So last week in exercise number 6, you were calculating these temperature anomalies. Now you're going to make a plot of temperature anomalies using data from Sodankula, I think. Yes. So we're dealing with a weather station in northern Finland from, I don't know, 1909 to 2019, so about 100 years or more of data, where we can look at how temperatures have varied in the winter, spring, summer, and autumn for the past 100 years. And what you'll see is some long-term trends in the data that come out from looking at the temperature anomalies. So you are given a data file for doing this. It looks like this. You're given some tips about working with the data. What's notable here is there is a t-average column. That's the average daily temperature in Fahrenheit, but there's a lot of missing data values in there. So one of the things you're going to do here is fill in our best estimate for the missing average temperature by calculating the average of the Tmax and Tmin value for the day. So it's just a kind of guess. It's not perfect, but it gives us a value that we can work with in terms of producing our visualization. So you will calculate what the average is for the max and min temperature and fill that in for T average only if there's missing values. So you shouldn't overwrite the observed values or recorded values with this, but if there's something that's missing, you can fill in the missing values with your estimate. You'll do that, convert your temperatures from Fahrenheit to Celsius because we have a data file in Fahrenheit temperature, so nothing new there. Calculate seasonal average temperatures, so for winter, spring, summer, etc. In exercise 6, you were calculating monthly average temperatures and then anomalies about those temperatures. Here, you're doing the same, but you're doing it for a seasonal average. So be aware that winter would include December, January, and February. However, ideally, winter of the year 1909 would include December from 1908, plus January of 1909 and February of 1909. So there's a little bit of bookkeeping here that you have to pay attention to make sure that your winter gets the right thing. Because otherwise, if you include December, January, and February of winter from 1909, it's the first 2 months of the year and the last month of the year, which is not the same season. So be aware of that. Then you do the same thing like you did in this past week's exercise of calculating the average temperature from some reference period to be able to do this calculation of the temperature anomalies. And then finally, you will plot the data, and we hope that you will use some markdown cells to describe what you're doing and help us understand what your code does. And this is an exercise where using things like large language models is acceptable. Like before, you should acknowledge how you've done that. So there's, you should add a section to the notebook called acknowledgements where you say, for instance, if you've used ChatGPT, what you've done. And also you should give a description of what you've given as prompts, or enough information that like we could follow how you have produced, for instance, code if you have used a language model to do so. And as a reminder, failure to acknowledge the use of these kind of tools is treated by the university like the same way cheating would be. It's not very nice, so please don't forget to report if you've used things like ChatGPT, because it's okay to do that. You just need to tell us that you did and how you used it. Then on the course page, you can find information about the grading. I think, yep, it's here. So have a look at this too, because this is going to give you a sense of what your score is going to be based on. One thing we have changed this year is we have distributed the points a little bit differently, because in years past, all of the different sections were equally valuable, and some of them were far more work than others. So we've tried to scale now how much points different sections are worth to be proportional to how much work you're putting into them. So things like, for instance, down here at the bottom, the code comment and style, it's good to do this stuff, but it's worth 2 points out of 40, whereas the section up here about aggregating data is worth 12 points out of 40, because the data aggregation step is a major part of what you do in this exercise. So you can have a look here at the grading criteria. They should be fairly clear and indicating, for instance, that if you get full points for reading the data file, you'd get a full 4 points, and you should do these things like read in the data file, skip the header row, and convert the -9999 values to be not a number. It should provide, I think, enough of a framework for you to get a pretty good idea of how to proceed with it, because I will show you the notebook that you'll start from, which is also a bit different than the earlier exercises in the sense that it is empty. So the training wheels are coming off this week, or whatever, the next few weeks for the final exercise. But you have all the pieces. You've gone through the steps of following a much more structured notebook to do almost everything you're doing in this exercise. There's some small changes to it because we don't want you to do exactly the same thing you've done before. But the difference here is like now you can show us kind of your level of understanding about how to work with these notebooks, how to do the Python programming, which might feel somewhat intimidating, in fact, probably does. But it also can be a really good thing for yourself to show yourself how much you've learned in the course, because I think, a good number of you probably hadn't done any programming before coming to the class. And when you leave saying, cool, I can make a Python notebook and make these visualizations, read data files, you can really see how much you have progressed in the last 7 weeks, which I think is kind of the most fun part of the course. But yeah, question? Yeah, I mean, if you want to copy markdown text from some of the other exercise cells, I don't see any reason not to do that. I mean, if you want to like copy in the headings and things like that to give the notebook the structure that you want to use.
Like just like for myself, so that when I'm working, I don't.
Yeah. Yeah. I mean, if I was in your situation, you're given these different tasks to do, and you're given the sort of different sections on which the assessment would be based. You could take, for instance, each one of these numbered things that you're supposed to do and make a heading for each one of them, and then copy paste the instructions in there. Maybe you want to delete them because it should kind of read like a document, but you could leave the instructions even in there saying like, here I read in the data file using pandas and convert the NA values. I mean, that's the point of the notebook, is that it's meant to give you the structure to help not only you, but also others who look at it understand what you've done. So absolutely, that's totally fine. Yeah. Any other questions? Hopefully I haven't made the anxiety levels spike with this empty notebook. It was kind of more dramatic than I was expecting to show this single empty cell. But if there aren't any questions, as usual this week we will have the help sessions on Thursday and Friday. You're welcome to attend those. If you have questions outside of those help sessions, it's best, of course, to put them into Discord or to contact one of the course assistants if you want to talk with one of them. But other than that, I think that's it for the course. And once again, hope that you feel you've learned something, and best of luck with the final exercise and exercise number 7.